Thank you, Patrick. We've just had lunch, and we are going to spend the next 2 slots with UnConference format. People have put topics on the board. We will run through them, come up with very clear descriptions, and then we will go lightning round on them. Yes, sir.
So I have, ooh, wow, that's loud. I have 4 of the 5 things on here, so.
And we thank you for it.
Because apparently nobody else wanted to get up and, anyway. So the first thing, just sort of a continuation from our discussion on Saturday about both the desire to have some ability to collect activity traces for performance, but also to be able to collect data that could be used for auditing. And I realized overnight that these are almost the same. The thing that distinguishes them is that for auditing you need file names, which is really expensive. And so maybe there's a way to do that. If we could get a performance mechanism that gives us, object numbers, say, then maybe we could get...
After the fact?
Yeah, then maybe we could reconstruct, or even just not right in the I/O path, but in another thread somewhere could figure out.
Number 2.
Number 2, I'm going to skip this one. This one's not mine. So... there's a lot of documentation out there. There's a lot of documentation out there from 2005. And it would be good to have some up-to-date recommendations for a range of use cases for how the hell do you set this up. How should you configure your pools? What tunables should you use to get the best, or at least the most understandable, reliable performance from various for various applications? Are there any rules of thumb that maybe either we know now that we didn't know before, or that maybe we used to know and now we really shouldn't? And sort of related to that, we see a lot of people now in virtualized environments where you have, your only pools are single VDEV pools. And is there anything special that you need to do to actually get the best performance in that sort of environment?
And perhaps reliability?
Yes. And so the final thing that I put up here is it would be really nice to have some automated pool setup tools. I'd like to be able to write a specification that says, okay, well, give me, 4 spares and 28 mirrors on this 60 drive blob. And have it automatically figure out not only which 60 drives those are, which isn't, usually isn't hard, but also things like, what paths are in common between these drives so we don't place 2 drives in a mirror that are on the same controller or the same lane of the SAS link or what have you. And there's a bit more discussion underneath here. For some of this, for the actual physical ID of drives, FreeBSD has a tool called SESutil, which is awesome, and makes me sad whenever I have to deal with Linux, because it doesn't have that. But there's a lot of OS-specific ways to do this, and I think even not all of them necessarily expose the information that you really need to do it right. But that's something that sort of would be nice to have, as a sort of bag on the side tool for at least people who do a lot of setting up of pools. And that's it for me.
Thank you. So number 5 went up and caused some initial confusion. Could you come on up to the stage, Mr. Racktop? Initially, faster Z-pool import, and the comment was, we've optimized all the things. And it came up that, well, in an HA environment that we will get the details of real soon. So let's hear on about that one. Welcome.
Hi. Yeah, so earlier on when we were talking about the ZFS channel programs and, creating data sets, and apparently mounting the data sets from the kernel was a problem. And then it sort of occurred to me that the import process does a lot of the mounting in user space. And one of the things that we keep trying to do is, optimize the import process because, in a HA environment, every second counts when you want to get the system, get a port imported on another head. So, yeah, just wondered why don't we do that from the kernel?
Number one, the subtle differences between collecting perf data and user activity, which may need some post-processing when it's coming in fast and you want to make sense of what actually happened after the fact. Do you have a use case you can describe?
Well, I mean, so, obviously this is a mechanism that we don't have yet. And we talked yesterday about it would be really nice if we could collect some performance traces that could be used for, for testing or for regression testing or what have you. And that mechanism, in order to be able to give out recordings, has to not have names in it, in addition to not having the data. But for auditing, you want exactly, I shouldn't say exactly the opposite, but for auditing, you want something that has the names. Names are really expensive at the VFS layer. And there's a couple of different ways that you could do it. One of them is to actually do that same call that ZFS diff uses and just block every activity until it finally returns, which I don't think is very popular because that's worse than a 60% performance hit if you had to do that for every I/O operation. And so maybe there's some ways you can cache the results of that and it wouldn't be so expensive. But the other way is if you can just have an interface that just spits out, object number, operation, credential, and then something else can do the post-processing to figure out, well, what is that object number? Now, one of the issues is that you have a, Jan has his hand raised. One of the issues with that is it's kind of a time of use issue, because what that object number is or corresponds to in the namespace may not still be the same thing if you have to post-process.
Question.
Go ahead.
Would it be possible to use inode numbers which are not reused? So if inode numbers are at least 64 bits and not reused, would it be good enough to have your audit stream use inode numbers and then have an interface to find name changes?
Well, inode numbers do get reused in ZFS after, I think, 100,000 deletes or something like that. We circle back and recycle inode numbers so we don't just run to the end needlessly. But the other issue with that is you have, like Rod and I were talking earlier, if you do the somewhat common thing of create a file in /tmp and open it and then immediately delete it, and then you can write stuff to it and your children can inherit that file descriptor,
yes,
but nobody else can access it. If somebody else creates a new file with the same name, if the audit log only has the name and ties it to a file descriptor, you can create confusion about which file existed at what time, and two different people wrote to two different file descriptors, but they both say they were the same name, but only one of them could have been the name at that time. And it gets to, like Garrett was saying, the time of use versus time of check. And so it gets quite complicated. And then you also have issues like if there are hard links, even if you use the ZFS diff mechanism to look up the file name, you get a file name, not necessarily the file name.
What I was thinking was,
the YouTube delay is worse than a satellite.
We're crossing the Atlantic.
So there's a lot of lag. So the idea is that basically replicating the stream of name to inode mappings as one stream and the stream of all the VFS operations as a second stream, and you could correlate them and you could subscribe to one stream or the other, or both if you need both.
Potentially, if someone cares to implement that. I think, I'm not sure if all the folks who were here yesterday for the auditing discussion, I'm not sure if that is enough assurance for what they're required to do. But I think, from my perspective, I would be interested in this not from a regulatory perspective, but from a more like an incident response perspective, where I would like to be able to figure out what is that activity going on right now, or what was that activity that was going on a few minutes ago, versus not the auditor shows up and wants to know on a particular day 6 months ago who touched this file, which is a different requirement. But I think in that case, like they do understand statistics. They are sort of familiar with that kind of reasoning. So, I'll leave it to those people to say, whether that actually satisfies them. I think we don't have the mechanism for any of this yet, but this is still it would be really nice. But if we did the mechanism for the performance stuff, which would be really nice for a bunch of other reasons, then maybe there's at least a pathway that you could see through that for also doing the thing that the auditing people need.
Stu chimed in.
Yeah.
Audit needs point-in-time access / change / file name recorded. 1/0 perf recording needs delta time of X file size with Y block size and all of the stuff listed on B7 of the user hackathon doc, which is, maybe I can bring that up in a sec. I hope that helps.
Like, I think talking to Garrett earlier, that the performance really just needs, read of this size at this offset. Like he was saying, he kind of wants the performance tracing to be slightly anonymized, so it doesn't need to tell us what file, just that we had a read of this size at this offset, so that we can replay that and compare the performance with and without some additional tuning or whatever.
So I think for performance, you do want the other operations.
Right.
You want to know, if you have a workload that's very, directory lookup heavy, you want to have that reflected in the trace.
Mm-hmm. For sure.
Generally, I wonder how much accurate could be a replay of recording in general science if we can track what exactly operations are sequential, which are parallel. Because without that, if we try to replay just all the stream of requests in parallel, that will be very much different if we replace the same sequential. And we can try to do it per process, per thread, but I'm not sure whether any of those will be true. Yeah. Is there any practical experience of replaying streams of unknown origin? How accurate is that?
Network people do it for network stuff. I think Rod was talking about that yesterday, if I remember correctly.
Right, packet drill and things like that.
There's the doc for what it's worth. Thank you all who are editing it, because I can't right now. Anything else on that topic of the subtle difference of on-time, real-time performance things where we need that fire hose of data, and then potentially post-processed audit logging that is hopefully still valid in a meaningful way, unless things move, the torrent is so quick that, well, maybe we're barking up the wrong tree. Yes, George.
One question kind of for everyone is like on the performance front. I'm hearing a couple things. One is like we want to track the performance kind of for the logical operation versus the physical, or do you want the physical operation as well writes to this offset of this file translates very differently to what happens at this VDAV, this offset.
Yeah, like when I was thinking of it, the original impetus was, we have a real world workload. Can we capture a minute or 5 minutes of that we can use as a benchmark to compare different tuning? But to your point, we can't necessarily record the physical part, because maybe what we're trying to test is if we react differently to the logical part, do we get a different physical breakdown? Can we get testing, Alexander and I were talking about changing the way aggregation happens at the VDEV queuing layer. And if we could have the same workload and test before and after that change and be like, okay, with this workload, it's that much better. And if we have 10 sample workloads, then we maybe can tell this is better in almost every case or in every case. But how do you decide where to record that, right? Because if you go too logical, you need file names and so on, and you kind of have to presuppose that files like that will exist for the benchmark to use. And then if you go too physical, then most of the things we want to test, you wouldn't be testing because you're replaying the same physical as the untuned workload. So I don't know what the right place to try to record a performance trace is.
So I could certainly see, if you were trying to do this in the most general possible way, which might not actually be a good idea, but I could certainly see you have sort of, a view of an operation on entry in your trace, and then when that operation retires, you know what happened to it physically, and you can put that in a trace too, conditional on whether you actually want that information or not.
Yeah, I can see how that could also be useful just to be able to compare. It's like the same logical operation resulted in these two different physical operations, and it's something we could actually look at, whereas now you're kind of left to kind of guess what ZFS did differently and why it was faster. Not just that it was faster, but why. Did it actually result in bigger aggregations or different queuing or what? But if you're tracing at the logical level, it kind of presupposes that the file that the trace showed that they opened and read from and then wrote to exists for the benchmark to try to replay. And that's not likely the case. Seems like this will be hard to generalize.
And how might a database throw that into the wind?
And like Matt said, how do we correctly record which things were happening from different threads versus the same thread, or, the right levels of parallelism?
Is there a hackathon topic hiding in there beyond what Stu put up? Which is still kind of hard to read. Number 7.
I think the auditing thing is definitely something I'd like to look at. I just don't know how much we get already, how much more we can easily get, and how much more is going to be very difficult to get.
Yes, Jan. Delay.
So this sounds like we have at least one more layer of nesting, so that you have a name layer, a logical file layer, and a physical transfer layer. And if the overhead is supposed to be low, it almost sounds like this is similar to the counters framework, where you need an event stream per CPU, so that you don't need locking to append to it. Of course, that introduces the next problem, that this buffer can overrun.
Anything else? Anything actionable in there? There are clearly so many different use cases. One is someone simply put up HIPAA. Well, that's one unique use case. We had quite a bit about the MPAA Trusted Partner Network yesterday, and Greg gave us a great overview of why it was a deal breaker and why he had to rely on third-party software to achieve the compliant logging. And without further ado, I'm happy to move on to the next one. Documentation. I have a blog post out there that's not too hard to find on callfortesting.org because it's the most recent, that simply says, stop blogging, start documenting. We are all guilty of blasting out something we discovered and making a quick toot about it or whatever little social media post, and that's better than nothing, but often great wisdom gets lost there. So fast forwarding from the sun glory days to this middle era to whatever's next, what are the top sources of documentation? Who's taking responsibility for the fact that, well, if you search on a popular search engine for anything related to ZFS, you get a whole lot of Oracle material, which may not apply to OpenZFS. And if someone has the magic wand to the documentation problem, please raise your hand, because I've struggled with it in various ways for years. You brought it up, Garrett. Was there a task where you found documentation that was not accurate, or it had never been written, or it was what?
I mean, so a lot of it for me has been, I'm really playing a lot of my server design by ear. So, I sort of have a feeling now after doing this for 12 years, like, what's a good way to set this up? What's a bad way to set this up? But, I never found really good documentation for, hey, you have a 60 drive server spinning disks. How do you set this up? How do you, what are the performance trade-offs? How do you figure out whether you can perform well on a RAID Z versus needing to have mirrors? What particular tunable settings do you need to make it actually go fast? I actually found, thanks to some blog post somewhere, like a list of recommended performance settings that I basically applied to a bunch of servers back 8 years ago, and well, kind of getting back to the performance thing. I don't know if they really worked or not. The users didn't complain about them, so something must be working okay. But I think in general, sort of, there's so many different things, different settings, different ways you can set things up. And there isn't a whole lot of documentation that's sort of at a high level of, I want to X, how do these settings interact, and which ones do I actually want to tweak to make things go fast, or to make things as reliable as possible, or pick your other objective or application if you have a specific application. If you're doing video streaming, then that's going to be maybe a different set of settings than if you are doing, machine learning crap like my users are, where it's like, okay, well, I have 1 million Conda environments now, each with 1 million files in them, and, not all of this is readily transferable, but I feel like there's at least some sort of fairly high-level bits and objectives that the documentation ought to be able to answer.
Does anyone have a test suite that they throw at each new system just to make sure it's 60 drives that all behave vaguely similar, or one that's actually a slipped-in refurb that ironically can sometimes be a lot faster, I've noticed with new firmware, that we probably can't get for the old ones? Or I trust IX has quite the exercising tools before shipping one of your products.
Obviously, we are pre-testing all the new build systems as added feature of appliance, but it's something in-house when we're speaking about production stage. On the other side, we're obviously doing benchmarks when we are developing systems and updating software as part of engineering cycle or development cycles. But that's not, obviously it includes some tools, but it's a big know-how and big set of work for a team of people who is doing that 5 days a week for 8 hours. It's a lot of manpower, a lot of internal knowledge, not exactly share. Speaking about all the original question, I'm big opponent of tuning. I don't believe in tuning. If something universally helps, it must be default. If it's not default, there must be a reason why it's not default. It may help in some cases, but not in other cases. And I'm a big proponent of trying to make things self-adapt, self-tune, adjust, or at least I've noticed that if we have some sort of threshold between two behaviors, it should better be soft rather than triggering. Just recently, after looking on Linux memory pressure for ZFS, I found like was trivial things. We had threshold of denote limit or threshold when we start arc pruning, and it was hard-coded as value. Okay, it's hard-coded, we reached it, we start pruning, we recover, everything is great, but it appeared that it was a hysteresis window of like 5-10%. 10% size sounds like not a lot, but 10% of many gigabytes is many gigabytes, and it creates significant spike. And it was trivial, like couple line change, just instead of threshold, when we start jumping and doing things, just do it linearly, just as further we go, prune more, slightly more, and then there will be no radical jump between two states. It may be not perfect, maybe some different curve shape could be used, but simply having something without step already changes things a lot and make it that specific tunings and its tunings much less critical. System should more or less self-adapt to that situation.
I think that's actually part of the point, is that a lot of these things may have gotten to the point. I don't have one. It's up for us.
No, yeah, let me bring it. Sorry, I used it for this. No, don't be. Oh, got it, yeah.
I think that may be the part of the point, though, is that, a number of these things may have changed to where they are self-tuning now, but there's still all this documentation lying around that says, oh, you need this special setting to make it run fast. And that's not true anymore. And maybe we need to get better at figuring out where that misinformation is and getting it excised.
No, yeah, that's true, but then it should better not tell that do this and everything will be great and better, but why it's getting better, what exactly Tunable does. The problem, I guess, after a couple of reposts, it will disappear. That's how it probably normally happens. And hard to say how to organize all the community to do the right thing. But what's about our standard documentation? All the ZFS properties are documented, but they're documented in what they are doing, not what you should do. If you go into ZFS documents, that for every property we have default value and description, what does it do? It doesn't try to tell you change everything and things.
So, I think there's at least a niche for some kind of documentation that says, hey, people used to say that you should do this and you shouldn't do that anymore.
Revised best practices.
Yeah, and maybe even with here's a link to the PR where we fixed that, or something, just so that people know, if they have 15 years of cargo culted configuration parameters, that they can just not do that.
We can have nice things. There was a quick comment from the chat of the burn-in test suite. I know as each vendor has their thing, but maybe we should think about what a common Kobayashi Maru, how do you pronounce that you throw at a system and see what comes out of it, rate it accordingly. I've long liked the SNIA SSS PTS, the solid state storage performance test suite, which profiles physical mechanisms and does pretty graphs and has a standard benchmark reference of all the things we test, but that doesn't work its way up the stack past the hardware. So maybe the SNIA folks can help.
As I mentioned yesterday, we licensed the Spec SFS 2014 benchmark
Missed that.
specifically to try to do some of that. And that was where we sort of ran into the issue of, well, we don't think any of the workloads in this benchmark are representative of what our users do, and how do we get activity traces that we could actually use to more accurately reflect what the people that we care about are doing. I'm not sure if that benchmark is still being developed, but it came out of the Spec consortium, the same people as Spec Int and Spec FP and all those classic 90s benchmarks.
Any Spec users in the house? Anyone?
It was actually pretty cheap to license it. It was like $1,200 or something. So it's like 222T drives. I mean, it's not that expensive.
So we've touched on pure documentation, yet the fact that when it hits all those syscontrols, all those KTEX, all the things, yes, often it's...
I would summarize it, if some documentation tells you go change syscontrol module parameters, things like that, my answer, don't. Unless you understand what you do, don't touch it. If it goes like what people should do, or what we should document if we don't yet, it's how to do proper pool topology. What's a block sizes and how to tune that. What block size is good for what. What pool topology is good for what block sizes. Like, don't try to put 4 kilobytes blocks anywhere first, and second, don't put them on RAID Z, don't put them on DRAID or anything. If you need very large blocks, put them on DRAID. Moderate size blocks are likely RAID Z up to certain topology of RAID Z. RAID Z of 3 disk could be okay. RAID Z of 8 disk okay. RAID Z of 20 disk are likely not okay. Some recommendation like that, and we see that regularly on the level of TrueNAS support. Obviously, when we do it for commercial customers, we have sales engineers who do it right always. On the level of community, we have documentation on truenas.com site, which describe all the pool topologies, pros and cons, what should be used, about that level exists. Honestly, I don't know whether we have documentation that within ZFS. Likely we should. We have some generic documentation which is not like pool documentation, but I never tracked who is updating that and how. Maybe it would need some work, but definitely what's about pool topology, dataset properties, that's what user should tune, and but it requires proper understanding. The question is that not to write a lot of words, but how to compact that into a reasonable document users would like to read. The problem, like I learned 20 years ago on previous job, and as long as you write more than one paragraph, nobody read it. So it must be very condensed and very in a proper place to be found, because person who is ready to read 10 pages will likely read them and find it and solve. But 90% of users just won't even try to read. They create something, they find terrible performance, and then they ZFS. Complain, hey, this ZFS is terrible, or NAS is terrible, or whatever.
And one small point from yesterday, there must be a perfect icon that's bright red that shows this is a creation time property that you cannot change later. You will regret if you get this wrong, whereas all these other things are infinitely tunable, but this handful are just gonna get you if you get it wrong. Anyhow, are we good on docs to get the juices flowing? Any other thoughts? User question, Patrick? As we're ping-ponging here. Go ahead, Alan.
Okay. What Matt and I were talking about earlier is, right now, if you look at the tunables, like on Linux, where it's under sys modules, ZFS parameters, if you are working towards one of those and you hit tab complete and your shell is like, are you sure you want to display all 247 possibilities? We thought about namespacing off a lot of the debugging ones into somewhere else so that they're, A, not as tempting to people that really shouldn't be touching them, but also just to make it easier to find the ones you're meant to maybe look at and the ones you're definitely not. I don't know, do we have ideas about kind of I hate to change the name of a bunch of those because that's always annoying when the sysctl or the tunable moves from here to over there. And we tend to create the compatibility shims for that on FreeBSD, but I think more thought needs to go into organizing those when we do add them and creating more structure.
Maybe some restructuring could have sense, but I honestly don't believe I have no good idea how do you separate debugging versus production versus something else, because when the feature is new, is implemented, you don't know what's the right answer. You may add the tunable, or just sometimes I add tunable to not hard code something in a binary.
Yeah, just not have a magic number, right?
Yeah, just make it tunable just because I can make it tunable. It doesn't cost anything.
Mm-hmm.
There's no processing overhead or something. But it doesn't mean it should be tuned. On the other side, if we're gonna rename it each time it says use it or not use it, then will go nowhere. Maybe, I don't know whether Linux allow hiding some properties. On FreeBSD there are some ccTLs that can be hidden. And we could add some flag, okay, we have this property, but don't show it unless somebody knows what to look. Mm-hmm. Like debug messages are not shown by default unless you know the ccTL name.
Otherwise, right, so that when you're walking the whole tree, you don't accidentally trip over one that's got a 4 megabyte payload.
Go ahead.
Maybe we could add a flag just to mark something to hide, but I don't know whether they can be hidden from procfs or whether it's a good idea.
I don't know how that works, because like the way it works on FreeBSD is the sysctl's there. If you call it by name, it'll work, but it doesn't show up in the listing, so that automated tools don't stumble over it and try to read, your debug message log. That's just going to be this giant ring buffer. And something like that to reduce the ones that people shouldn't be looking at some more could help. But I agree that, when we create them is usually not the time when we know whether it's something that people are going to need to touch in the future.
I don't think it should be part of the name. It should be somewhere out of scope, some other flag. I don't just, other than hiding it like from ccTL, I don't even know where to expose that flag.
Yeah.
Thomas from YouTube commented, at least a name for the guide, The Hitchhiker's Guide to OpenZFS. Any final thoughts? Moving on, in many virtualized environments, you have a single, highly synthesized VDEV to play with. Can we share with the world some best practices, or shall you ask for 2 of those and mirror them and just hope for the best, or copies equals as high as you can crank it, or others? Is there anyone, a hoster, doing a whole lot of virtualized ZFS to customers, or how do you handle that? Andrew, grab a mic if you've got something to say. That's cool. They'll get us started.
For me, for most of my customers, they really don't know directly that they're on ZFS for a lot of stuff, because they're running Linux, and the ZFS side is sitting outside of their vision. So, they may be having a single volume that may be running something like XFS or something that's just sitting in a ZFS environment, so that I get all my snapshots, I get all my protection at those levels, at the lower levels. So I don't know if I can give a sensible answer.
I think in general, if you're using ZFS inside a VM, the biggest one is, the same as it is on real hardware, trying to align your record size and the sector sizes with what the abstraction underneath is. Although oftentimes when that's provided by someone else, you don't know the answer to that.
Can you sniff for it?
Maybe to some degree, mostly experimentally, which is not necessarily going to be that helpful. But
Because the vendor might not want to actually tell you.
Yeah. Or not to promise that it's a certain thing when they might not change it later. But obviously, smaller is more likely to have less problems, but it also has an overhead. So finding the right mix really depends on your workload. But to Mav's point, generally ZFS will do the right thing out of the box. It's like if you really want to play with it. You know, if you break it, you get to keep both pieces.
So I know in our OpenStack environment, you get, the clients get, the standard VirtIO virtual disk, but that's just exposing what the hypervisor thinks is the actual parameters of the disk. In reality, we're running on Ceph, which means the block size is 2 megabytes. And you're obviously not going to be tuning your VM file systems to have 2 megabyte blocks, because that would just be insane. And also because there's a big pile of caching and operation coalescing inside the hypervisor to basically make that not be visible to you. And I assume the commercial clouds are doing similar sorts of things, because I think most of them, maybe not Amazon, but I think a lot of them have done the same hack where basically the block service is built on top of an object service.
Virtualization environment, but I was thinking that at this point ZFS has only one way of adjusting to underlying storage is a shift, which is pretty limited by their maximum size it can cover. You'd probably, I think maximum allowed some 16K, I'm not sure even 32, but you should, in many configurations, you don't want to go that high, especially if it's RAID Z. No, if we're talking about single device, it's less critical, but definitely not RAID Z or D-RAID or anything. But I was thinking at some point if we could give ZFS another layer of optimization, which is not so strict, because a shift is practically logical block size. And we are already, after a number of iterations, I think we've done as much as we could within that range. So ZFS should self-tune. In some cases, it should use bigger shift. In some cases, it should follow a byte, whatever is required, but not enforce what's optional. But would be good if we made, on development side, obviously, if we could make ZFS have one more threshold to optimize I/O on level of block allocation, or on level of I/O aggregation, where we could say this device has 2 megabyte blocks. And if somebody happened to write 2 megabytes, let's write it, align it at 2 megabytes. If it won't create us too many holes, or if we aggregate I/O, maybe, I don't know whether it makes or not sense to aggregate across different stripes, but it may have no sense to aggregate, since we may get response faster. Like if we need to read something, 2 sets of blocks, but they're from different stripes, maybe send them separately and one answer sooner than another. So I was thinking about things like that, but so far it haven't realized anything, but that's another idea that's floating around. Would be interesting, I think.
The comment I was going to make is, especially for commercial clouds, I'm not sure single VDEV is a good configuration at all. Because when you start thinking about commercial cloud vendors, they're going to give you a volume with so many IOPS and so much throughput. So it's, the cost of that might work out better to actually create 10 smaller, devices, so that you get more bandwidth, more IOPS overall than just one larger device. So I sometimes wonder whether a single VDEV pool is of value in many configurations.
In addition to background performance, I would kind of second that from a point of ZFS performance science. With one VDEV, we only have one VDEV queue, which limits IOPS. We have several we may have several allocators that spread it slightly through different areas, but still limited number of areas per device, and there could be some bottlenecks. So I think several VDEVs may actually work fast on level of ZFS2, especially if we talk about small block I/O, small block workload.
Is this documented anywhere?
It's just experience and know-how from a lot of profiling. I don't think it's documented.
That goes back to question number 2. Was there?
Yep.
I mean, this was actually originally, as a sub-point of the previous discussion. So,
If it's a topic, it's by extension a documentation topic. It's as simple as that. It's pretty universal.
Just to kind of go back to the documentation thing, I don't know if this would be beneficial because obviously coming from the development side, we have certain tools that we use and kind of set up. But I often wonder if like users, whether we use like GitHub to create a discussion page for like, this pool configuration has worked really well with X tunable. Like this tunable actually made a difference, so that those on the development side can go back and say, why did that tunable make a change? Like, why is that beneficial? Maybe the default values that we have are incorrect. And in my little test configuration of 4 VDEVs comprised of 1 gig devices, it works fine. But in the real world, when somebody's actually using this in production, it doesn't perform the way we kind of tested in our development environment. So maybe there is a way that we can start collecting what are configurations that people have had success with or tunables they've had success with. Kind of, Garrett, to your point where like I read a bunch of blogs and I find these things that work, but maybe we need to start consolidating those and then using those to kind of create, actual code changes or modifications or better documentation once we kind of see patterns where it's like, oh yeah, when you go with these really wide pools, this works better versus one that only has like 5 VDEVs. Something like that might be a starting point.
Oh yeah, in some cases, sure, we could tune some defaults. In other cases, maybe we should think about rewriting the code differently. Yesterday I mentioned that I have a lot of itch to rework some algorithms in L2ARC writing, and that would remove a bunch of tunables from that area which right now don't work right. And it's permanent. That's the area when tunable actually makes sense, but it should be fixed. Do not require that, because for L2ARC should be 1 tunable. How much do you want to stress that L2ARC? What sustained right performance do you expect there? But we have right now probably half dozen different tunables around it, and it should be 1.
And another icon to go with it. Congratulations, you just benchmarked your RAM. Great. And then when you threw a real load at it that blew that buffer, suddenly, oh, it's terrible. Well, yes, fine. Has anyone else encountered this?
Not this specifically, but we did a lot of work in this area recently. Part of it was reinventing stuff we eventually realized that Matt had already done in a later version of ZFS to fix the way the log space map works, so there would be less log space map to replay and that it would replay faster. But then Don and George worked on parallel import, so that when you have more than 1 pool, we can be importing those at the same time. And then myself and Alec at last year's hackathon did import progress, so you can only see what's happening when it's taking a long time and know how far through it you are, to know, do I want to give up? And especially if you're doing, if node A goes down unexpectedly rather than on purpose, and you're importing on node B and it's taking a long time to the point where node A is back up, you might want to abort and actually do the import on node A again rather than wait for it to complete or not. And then for the graceful case, again, Don did the parallel export and then also the asynchronous arc eviction, so that as part of exporting on the pool that's about to go into maintenance, we take the part of freeing all the arc buffers after the export's done, so that the second node can already start the import while we wait for all that memory to get freed in the background. Those obviously won't exist on Illumos. I don't know, does Illumos have the log space map feature at all?
I mean, I think it does.
Okay.
Yeah.
Then it is probably missing Mav's patch from, was it a year ago or so, to fix the pacing on log space map?
Yeah, that's definitely greatly improves import time.
Yeah.
But I haven't tracked whether it got to Illumos. I don't know.
Yeah, I think it's definitely newer than what's in Illumos. So you might want that specific fix. That means we make sure we don't leave quite so many log space maps laying around that we have to deal with at import. Because if you have like 8,000 of those, then that's 8,000 random IOPS you have to do before you can finish the import.
Right.
Yeah. And so the import progress stuff that I did last year probably is very useful to see why it's taking so long. And then from that, you can decide if it's all log space map time, then that one commit probably fixes everything for you.
Yeah, it reduces dramatically by like order of magnitude.
Yeah, our customer went from like 9 minutes per pool to like 30 seconds per pool for import time.
One more thing that we were cleaning up within last year, mostly Amir Hamza from our team, is that we clean up some mounting process related to property setting, to like no mount, to changing mount point and other things. To make sure we don't mess up system during pool import, we always force wiping mount points on the pools to make sure the structure is predictable, nothing is cross-mounted, who knows where. And we found that it's better to first import the pool without any mounts, and we don't do it, but we could do it in parallel and pretty fast. Then we set property, and with our later changes, setting those properties no longer triggers mount. Like if dataset is not mounted, that setting mount point will not mount it anymore. It was previously, and that created a mess. Because something mounted, something not. Right now, at least in 2.3, I don't remember whether it's backported. If something is not mounted, you change mount point and nothing happens. So you can change mount point, modify whatever you want, and then you can trigger mount recursively. That's another feature we added. Previously, you could either mount one dataset or F minus A.
Yeah.
Right now, you can mount one pool, one subtree of datasets. It's flexible on what you need to mount. So
that's a nice improvement.
Yeah. So.
But yeah, because I encountered a customer using the setting the mount point to cause it to mount. And I was like, that's an unexpected side effect in my book, and I'm glad to see that's fixed now.
Yeah, we cleaned it up at several commits probably over the last year.
Because I remember a feature that we had in, I think, Illumos and FreeBSD that didn't have in Linux for a while, but we got over there was the ability to set the mount point without unmounting it first or remounting it at all. It basically change the mount point and pick it up next time instead of.
I think it's now it's another feature we added some parameter to ZFS set. You may specify that while we're setting property, don't do anything like mount, unmount, share, unshare.
Yeah. Don't
do anything. Just set property and done.
Yeah.
So it wasn't possible before, but it's possible now.
Yeah.
Another feature.
It was renamed that didn't have it. So you could rename a data set and not make it unmount it and remount it in the new location. That was the one that Linux was missing that we added. But yes, very nice to have it on set now as well.
Okay, we are at the nearly 3 o'clock mark. We have some folks joining us from far away, so Patrick and I will fix with some cables and bits. But thank you so much for this, and we will rejoin in about 5 minutes. Thank you.